Hello and welcome to Maths Corner. Today, we are going to evaluate this integral using geometry instead of long calculations. We are given the integral from -3 to 0 of (1) plus the square root of 9 minus x squared with respect to x. The first step is to split the integral into two simpler parts, so we write it as the integral of 1 from -3 to 0 plus the integral of square root of 9 minus x squared from -3 to 0. Let's solve the first part. The integral of 1 simply represents the area of a rectangle. The width of the rectangle runs from -3 to 0. The distance between -3 and 0 is 3. So, the integral of 1 from -3 to 0 equals 3. Now let's focus on the second part. Let's say y equals square root of 9 minus x squared. To understand what this represents, we square both sides. That gives us y squared equals 9 minus x squared. Rearranging, we get x squared plus y squared equals 9. This is the equation of a circle centered at the origin with radius 3, so this expression represents a circle. But remember, our function is the positive square root, and square roots are always positive, so instead of representing the full circle, it represents only the upper half of the circle. That means we are dealing with a semicircle of radius 3. Now look at the limits of integration. We are integrating from x equals -3 to x equals 0. This covers only half of the semicircle, which means we are actually finding the area of a quarter of the full circle. The area of a full circle is pi times radius squared. So, pi times 3 squared gives 9 pi. Since we only need a quarter of the circle, we divide by 4, so the required area becomes 9 pi divided by 4. That means the integral of square root of 9 minus x squared from -3 to 0 equals 9 pi over 4. So the final answer is 3 plus 9 pi over 4. And that's how we evaluated this integral using geometry instead of heavy algebra.